All right, so we'll be having our first session on VDC of the data center CCIE preparation bootcamp. In this section, we'll be discussing about Nexus 7000 VDC feature, what it does, how do we configure it, what are the pros and cons of it, how it differentiates from other similar technologies provided by Cisco on different platforms. So we'll be seeing all that. If you have any questions, stop me. Feel free to ask any questions, and we can discuss all the topics in detail, right? Okay. So today's agenda will be on VDC concepts. We'll be discussing what are the different concepts of VDC, how it is created, how it provides benefits or virtualization within the Nexus platform to provide more isolated services, and making a Nexus 7000, the big switch, as small chunks of smaller devices by providing the same level of granularity and services in all the virtual devices that we can create. So VDC, we'll also be discussing about VDC resources, what are the shared resources and at individual levels. Then we'll be seeing about how to configure VDC, right? So there's a demonstration at the end of the session. We'll be seeing that, okay? All right, so VDC concepts. Now, what was the actual motivation behind creating the VDC, right? So think about a Nexus switch, right? Now, there are different models of Nexus switch. We have 9-slot chassis, we have 10-slot chassis, we have 18-slot chassis. We have other smaller slot chassis as well, but think about it. You have an 18-slot chassis in your environment in a data center, right? And there are multiple slots in it, but out of those multiple slots, you are not completely utilizing 2 slots, or maybe 4 or 5 of them. And at the same time, you need to set up another device for performing certain tasks, and you buy another Nexus 7000, say 7009 switch, right? So that actually increases your cost of the data center management and production environments, right? We don't need that. But at the same time, with Nexus VDC feature, what you can do is you can segregate this Nexus device into 4 smaller chunks, virtual devices or virtual Nexus boxes, in which they will look to the end user or within the data center virtually as 4 different devices, providing different functionalities, or even providing connectivity to each other, right? And at the same time, you'll be running physically all on one single box. So the cost of the production totally reduces because 4 devices functionality is being provided in just a single device. So that's the reason, and that was the main motivation of reducing the main cost of the data center production environments, right? So it provides logical partition of the physical switch. Each logical switch or the partition can be managed independently, right? So now you can have individual roles and users for each VDC, and each VDC, when you connect to or telnet into the management ports or management IPs of that VDC, you'll be able to manage that particular VDC environment, and you will feel like, okay, I'm just managing one single device, and the rest of the 3, it'll be like non-accessible, because that user that you have created for this VDC doesn't do any interaction with these VDC. Though you'll be sharing the resources of the same single device, but again, it's isolated, right? Software fault isolation, right? If you are, say, for you are hitting any software defect in one VDC because of, say, for you're running EIGRP, right? And you hit a software defect or even a crash, process crash or a hardware crash of a particular line card on that particular VDC, right? It is not going to impact the other 3 VDC functionality or the production traffic unless it's the main default VDC, right? So it totally isolates the fault to that particular VDC or the virtual environment. So with this, you can also run multiple instances of the same feature or same software features within all the different VDCs. And at the same time, you can run different features as well. So you can run EIGRP here, you can run OSPF here, you can run BGP or MPLS here, and just layer 2 features here. It's totally segregated. And you feel like this device, this VDC context just provides the layer 2 functionality and nothing else. All these feature processes will be running on their respective VDC environments, not on this one. So the system resources will be less utilized based on the functionality that you need on that particular VDC, right? So thus, it provides a better utilization of resources. All right? Virtual device context. Yeah. You have any questions?
No. Go ahead.
Okay. So VDC, as the name itself states, virtual device context, is an implementation of virtual contexting in Ethernet switches, right? So Nexus device is actually an upgrade of 6500 switches in the Cisco product line. Earlier, a lot of the production environments like data center or layer 2 environments were running 6500 switches, but with introduction of data center switching and the functionality and the features provided by Nexus 7000, all those switches, 6500 switches were devices, the migrated path to Nexus 7000, right? Logical partition of the switch hardware and software resources to virtualize the control data plane and the management plane. So as I was saying, that you can virtualize the data plane, the control plane, and the management plane to each VDC. So what feature, the forwarding features you're running, the control plane features or the management features, management roles and users that you're using on one particular VDC is constrained only to that VDC. It doesn't matter what other features are to the other VDCs. That doesn't really matter what you're running on that VDC, right? So it totally virtualizes all these three planes, right? All the VDCs on the switch have their own management plane, control plane, and data plane, as I explained it before, right? But remember, each physical interface can only be part of one single VDC. It cannot be part of two VDCs. You can have individual line cards part of VDCs, but you can also have segregated interfaces or distributed interfaces per VDCs. Say for you can have, say for there's a 48 or 32 port switch line card, right? You can have 8 port, 8 port, 8 port, and 8 port distributed in each VDC, right? But it cannot be that if there are 1 to port number 8, you cannot have the same port number part of the VDC 2. It cannot happen. It will only allocate to one single VDC at a time, right? So, thus the hardware sources like the memory and the backplane bandwidth is all shared across the VDCs, right? Based on the line cards allocation or the resource allocation that you have done for the VDC. Though you can, to some extent, control what resources you can allocate, like how many VLANs you can create, how many VRs you can create, how many port channels you can create, what kind of line cards you want to allow in particular VDC. You can control all that stuff. But again, that is independent of other VDCs, and they'll be sharing their resources from the main, the base hardware of the Nexus 7000. Right, and all that resources lie on the line card as well as the supervisor running on the Nexus switch. Right. So no L2, L3 switching routing across VDCs except through external connections. Now, what this means is, unless there are if there are two VDCs, whatever feature you're running here, it doesn't interact with the features or the connections being run on the other VDC, right? So say for you're creating a static routing routing, say OSPF on this VDC, and if you think that if you do redistribute connected, all the interfaces of this VDC will get redistributed, that is not going to happen. Only the interfaces of this VDC are going to get redistributed, all right? But if you are running OSPF here and OSPF here as well, and if you have a connection, a link between both these VDCs, like you have a link going between two different devices, then you can exchange their protocol information. That is the external connection, right? Unless you have a physical connection, they both are not going to interact with each other, all right? VDC properties. Each VDC is treated as a standalone device, so whatever allocation you are doing based on that, the resources will be utilized in that VDC. Now, say for you are specifying that a VDC can only have, say, 8 to 10 number of VLANs. All right, so it will only use the resources that are required for 8 to 10 VLANs that you are creating on that VDC. It is not going to utilize the extra set of resources for that VDC, right? Each VDC will have its MAC address assigned to it, which uniquely identifies the VDC, like in switches like 6500 or 7600 routers. Each router is provided with its own MAC address, right? So if you do show a MAC address table, you will be seeing that multiple interfaces have the same MAC address table, MAC address value associated to it, because that is called the router MAC. So similarly, in VDC, each VDC will be allocated a unique MAC address, which uniquely identifies that VDC in the network, right? So same feature, but again segregated because you have virtualized the device itself. So it is automatically going to assign a VDC, a MAC address to that VDC to make it unique within the network, right? VDC1 or the default VDC, by default, all the ports on different line cards within the switch belong to VDC1, right? Unless you allocate those interfaces to the other VDC, they are all going to remain in VDC1. They're not going to be part of any other VDC. You can create or delete the VDCs. You're free to do that. Though there's a limitation on how many number of VDCs are supported on the chassis, on the Nexus switch, based on the license as well. If you are supporting a license of 8 VDCs, you can create 8 VDCs, but by most of the times you have capability of 4 VDCs on a single Nexus switch. VDC defines the software fault domain within a physical switch. Any service crash in VDC doesn't affect the rest of the VDC context, right? So isolation that I was explaining before, that if a crash happens on a process called BGP in one VDC number 2, it is not going to affect the functionality of BGP in VDC number 4. It is only going to impact the functionality of the process BGP under the VDC2, right? If you do a reload on the VDC, you will have to issue the command reload VDC. You cannot just issue the command VDC. So it doesn't reload the whole switch. It just reloads the VDC and comes back up online. And that is pretty quick, rather than, I mean, if you compare with the whole upbringing of the whole Nexus switch, and as compared to the reload command issued on the VDC, the response time or the bring up time is very quick. So you can do that, and it's also isolating the other VDCs, right? So if you reload one VDC, it is not going to impact the rest of the VDCs, unless there are external connections, which are obviously going to go down, but it is not going to impact anything else. VDCs can have management domain assigned to it, and hence giving control to user, which has appropriate permission for the VDC. So as I was mentioning, that you can create roles and users for a particular VDC, and you can provide the management access only to those users. Now, if they are users, unless there are some users globally associated, like through authentication through LDAP or Active Directory, the same set of users can access all the devices in the network. You can have that, but if you are using some local or creating some local users, or even the LDAP-based users based on their roles, you can limit their accessibility within the same physical Nexus switch towards the 4 different virtual devices on that switch. So if you allow a user ABC to access only VDC 2 and 4, he'll be only, based on that role, he'll be only allowed to access or do certain things that you're permitting him to only on those 2 VDCs. The rest of the VDCs he cannot even log in or do or run any command for that matter, right? So for VDC, user needs to change the mode before configuring resources assigned to the VDC. So
in that context, I have one question. For the default VDC, right? Will those users have any access to default VDC?
Oh, you can restrict them as well.
Okay. So you can basically define what users get access to default VDC and what? Yeah,
so the switch is by default in VDC 1, right? Once you create all the VDCs, say for you have created 4 VDCs, right? If the user has accessibility to VDC 1, it doesn't mean that he'll have accessibility to VDC 2, 3, and 4. It is not necessary. And if a user has access to VDC 2, it doesn't mean that he will have accessibility to VDC 1. It all depends on the role and the permissions that you are allocating to that user.
Got it.
All right. Okay, so now in order to make any configuration changes on that VDC, say for you're not connecting via the management IP of that VDC, you need to switch to that VDC to make the necessary configurations of the VDC. You cannot make the configuration of VDC number 2 staying in VDC number 1. You can only allocate the resources from the default VDC, but apart from that, you cannot do anything or any configuration on the rest of the VDCs. You will have to log in into or connect to the VDC in order to do any configurations. Right? Okay, any questions so far?
No, I'm good.
Okay. Okay, so this is the architectural view of Nexus 7000 with VDCs or virtualization. So at the base, the Nexus switch runs on the Linux kernel, right? Then there's the infrastructure services that is provided by the Nexus OS, which takes the commands or the configurations from the upper layer services or applications and convert them into hardware understandable or provide services that could utilize the kernel as well as the hardware features on that Nexus physical switch, right? All the VDCs can run, have their own protocol stack. They can have their own set of features being enabled. Remember, if you enable a feature in one VDC, that doesn't mean that it automatically gets enabled on all the other VDCs. Though, if there are certain feature sets that you need to install them on the VDC 1, that is the default VDC, right? But you will still have to enable them only on that respective VDC. You don't have to enable them on the VDC 1. Say for you want a feature of storage like FCOE. So what you do is you do install feature set FCOE on the VDC 1, but you will use this feature on one of the VDCs, say number 3 or 4 that you have created, and there you will say feature set FCOE. You want to do that, right? or for that matter, you also have an option to create a storage-based VDC, right, which provides storage services in the data center environment. We'll be talking about that in the storage section when we'll be doing that. But just to give you a heads up that you are, by default, the VDC that you create are based off Ethernet services, but you also have the functionality to create a VDC which is of type storage. So it provides storage-based functionalities like fiber channel and all that stuff. Okay. All right. So VDC resources. So there are certain shared resources within the Nexus 7000 which are shared across all the VDCs. Now, these shared resources are common to the whole Nexus switch, and these are actually utilized by the VDCs to perform certain tasks within that Nexus VDC, right? So first and foremost is the kernel. Now, kernel is obviously going to be shared. It provides with the core of Nexus operating system. It is responsible for the communication between the hardware and the software. The same as the Linux kernel functionality that you have, same operating system one-on-one concepts. Whatever the kernel task is done is the same tasks are being performed by the kernel over here, right? Infrastructure layer. It is designed to facilitate the NXOS feature implementation or support the request from the higher layer towards the kernel, or to utilize the maximum or to make the maximum utilization of the hardware resources. So this infrastructure layer actually provides services to the applications at the top layer to understand or to communicate or to request resources based on the command from the kernel or the hardware, right? System manager, it provides with the fault and recovery management system. It takes care of killing the processes, restarting them, or tearing down the process. Whatever the stuff is related to process management or the fault management, it is taken care by the system manager. Interface manager, as the name suggests, it does the same thing, managing how to interfaces on the switch, creating a reference map of which process is utilizing which interface and what services on that interface are being mapped to the other protocols or services within the VDC or the whole Nexus switch. Forwarding information base, that is a FIB. It takes care of the data plane on the Nexus switch. So the segregation or the hardware programming on the Nexus switch, because it's a distributed forwarding infrastructure-based switches like the 6500s and all the latest data center switches. So all the Ceph-related information on the next Cisco devices is being hardware programmed so that hardware-based switching can be performed, right? So hardware programming has to be done, which is automatically taken care by the operating system, base operating system being run on that device. The same way here, the FIB takes care of the hardware programming done on that Nexus switch, which helps in doing the hardware-based forwarding for the layer 2 or the layer 3 packets out of that switch, right? VDC manager, so it takes care of creating, delete, or allocating the resources, deleting the VDCs, and it actually helps in doing a communication between the system manager and the resource manager. Because with the resource manager, it is going to request for the resources that it needs to perform the task or provide services within that VDC. So Resource Manager actually takes care of managing the allocation of the resources within the VDC, right? So all of them are correlated and play an important role for managing the whole Nexus environment and are shared across all the VDCs created on the Nexus switch. Make sense? Or any questions?
Yeah, that makes sense. Thanks.
Okay. Right. So this is the high-level view of with the shared resources. The same structure that we discussed at the back. So there are different VDCs. They'll be running different protocols or applications in that VDC. They'll be interacting with all these shared resources to get the services for that particular services running within that particular VDC, right? So the resource manager, the VDC manager, the SIB, interface manager, system manager, and the infrastructure and kernel. So these are the shared resources, and these are the resources specific or the application specific to that VDC, right? Remember, this IP stack is all segregated to the VDC. It is not shared across the VDCs, right? Interfaces. So by default, as I said, all the interfaces on the Nexus switch after booting up are part of VDC1, the default VDC. You have to manually allocate the interfaces to be part of a certain VDC, say for 2, 3, 4, and you can limit the resources or the module type for the VDC, say for there are F1 and M1 modules or the line cards on the chassis, and you want to provide only layer 2 services on VDC2, right? So you can limit the resources or the module type to F1, so it will only provide layer 2 services. You want to run layer 2 and layer 3 services on the rest of the VDCs, so you can make them as F1, M1, or you can, if you want just M1 modules to be part of it, you can limit the resource type for the modules for that VDC as well. So you have multiple options of doing that. And we'll be seeing more details in it when we go to the demonstration section. Okay. Super user has the permission to assign or allocate interfaces to different VDCs. Not all users have that permissions. And once the interface is moved to a particular VDC, say for Ethernet 1/8 to 16 has been moved to VDC2, right? Or 9 to 16. Only you can make the config changes of those interfaces after you connect or switch to the VDC2. You cannot make it in VDC1 or any other VDC for that matter, right? VDCs are aware of interfaces which are assigned to it. So once you allocate the resources, the VDC know what belongs to them, right? Moving the interfaces. Now, you can move interfaces or from the default VDC to the respective VDC. As soon as you move the interface from one VDC to other VDC, all the configuration gets lost, right? So if you have enabled layer 2, say for you have an interface on which you're running spanning tree or you made it a trunk port, and you move to another VDC, say VDC from 2 to 3, all the configuration will get lost, and you can, and if you want, you can, and if that interface supports, you can configure IP address and run OSPF on it. Yeah, nobody's stopping you from that. But after moving interface from one VDC to other, it is going to remove all the configuration on that interface. One other question is sometimes is asked is, what happens if we delete a VDC? What happens to those interfaces, right? Once we delete a VDC, what happens is those interfaces which are allocated to that VDC doesn't go back to the VDC1. It goes to the VDC0, which are the unallocated resource section, right? So they go into that VDC. Now, unless you configure another VDC back and allocate those interfaces, those interfaces are going to remain in that VDC0. It is not going to be used by any other VDC, right? So those will be unallocated, unutilized resources available within the system.
One question.
And you can, yeah, go ahead.
When you bring up, when you add a line card to the chassis, right, and you have like 4 VDCs, yeah. So way do the line cards populate? Where do the when the line card comes up?
It will be part of VDC1.
VDC1. Okay.
But after you delete it, after you delete the VDC, say for you allocated those interfaces to be part of VDC4, right? And you delete that VDC, then it will move to VDC0.
Okay, specifically on deletion, it goes to VDC0.
Yes.
But when it powers up, when you like install a new card, then it goes into VDC.
Right. So at the bring up time, it is always going to be in default VDC.
Okay. Thank you.
Right. All right. So the next section is VDC management. So I just added this section as though it is not really much discussed in data center examination, but still it is important for people who manage data centers and play with VDCs a lot. So there are different roles within the Nexus switch, which provides you with different level of functionalities you can do within the VDC, within the Nexus switch with the VDCs, right? Now, as I mentioned before, super user is used to help allocate the VDC interfaces, right? But super user is the one which allows you to create or delete VDCs. It allows you to modify the system boot configurations. And it is the only one which allows you to do a system reload. You cannot do that with any other role within the system, right? And obviously, you can do a resource allocation for the VDCs. Admin role, VDC admin role is only specific to the VDC, allows you to change the configuration for resources within the VDC, right? So like interface configuration or the VLAN configuration, or layer 2 configuration like you're enabling certain features like OSP or EIGRP or BFD for the matter, right? So it allows you that that functionality is only implemented through the admin role, VDC admin role. VDC user role is a basic user role, which provides you with a subset of commands that within a VDC that you can run, like you assign certain commands, show IP route or show run or certain commands that you allow a particular user to be allowed to run within a VDC. You can do that. And this is always created by the VDC admin, right? So it's just a simple slide that I want to share. VDC configuration and verification. I'll show you this in presentation, but I'll also show you as a separate demonstration section or the lab demo as well, okay? Now, if you want to configure or allocate resources to a particular VDC, you go to the config mode in the default VDC or the main Nexus switch default VDC environment, and you do VDC name, and then do allocate interface, and you specify the interfaces that you want to allocate to it. All other allocations are done on the same mode. So if you want to do like limit resource module type M1, you can do that over here. You cannot do this after going into the VDC mode, because there you have the role of admin, VDC admin, right? It doesn't have the permission to do that. It has to be the main super user role to perform these tasks. So the resource allocation is definitely the super user role which has the permissions to do it. Okay. All right. Now the show VDC membership command shows you which interface, what resources are part of which VDC. So if you see here, VDC1 and there are VDC ID 2. There are interfaces on slot 2 on this VDC and slot 1 on the VDC ID 2. You can also see that there's also VDC ID 0. Excuse me. VDC ID 0. Now, here there are no interfaces allocated. This is by default, right? And unless you delete any particular VDC, this is always going to stay empty. Once you delete a VDC, all those resources which were there part of that particular VDC that was deleted, then it'll move to the unallocated resources. Otherwise, it is going to be part of their respective VDC, right? Okay, so the same example that is shown here, how you allocate the resources and how you verify what resources are part of which VDC. This is how you do it, right? And then you have to connect to a particular VDC using the switch to command from the default VDC. So you'll say switch to VDC 2, and then we'll go to that particular VDC, and then you can do the respective interface configuration. You cannot do this configuration from the default VDC itself, right? Verifying the VDC resources. So if you do a show VDC detail, you will be able to see what all resources are part of a particular VDC. What is the HA policy? What is the CPU percentage? Not all versions of code show that, but yes, you can see that. What is the uptime of the VDC? So all that particular information related to that VDC, like if you see here, VDC supported line cards is F3 module, but if you see the other VDC, you can see that F2E, F3. That means it has more support of line cards than this one. You can see, I mean, if you have a F1 or F2, F1 or M1 line cards, you can see the same thing here. VDC supported line cards will be F1 and other side will be F1 cross M1, right? That is what you're going to see in the show VDC detail output. Okay, so in order to connect to the VDC from the default VDC, you issue the command switch to VDC and the VDC name. In order to move back from the non-default VDC to the default VDC, you issue the command switch back. Now, understand, if you are directly connecting to the non-default VDC, say using management interface MGMT0 and using telnet, right? You cannot, I mean, even if you issue the command switch back, it is not going to help because, first of all, you are directly connecting to that VDC and it's an individual device for the user that is connecting to it. So this is applicable only when you're connecting to the default VDC and you're trying to switch from default VDC to non-default VDC to do respective configurations or check some commands, right? So I guess that is it on the presentation. Any questions?
No, I'm good.
All right, so I'll stop the presentation here, and we'll see the lab section in another presentation, okay?
All right.